Hey guys, it's Chili here, and I think it's time for us to do a little programming. It's been far too long. But I've been busy with life and stuff, yada yada. You don't want to hear about that shit. You want to get to the coding. The problem is, I really don't remember where we left off. Let's see here. Yeah, we'll try that. Huh. Okay, yeah, I kind of remember this. Oh, yeah. I remember making this dude in my other program that I made for C#. That's kind of a clusterfuck. But that doesn't matter for this. Not important. So, yeah. So this is very simple. We're updating a surface sequence, I guess. So we made this last lesson, probably. Yeah, just a class which encapsulates a sequence of surface objects and allows you to iterate through them and draw them. Seems fairly simple. Alright, and what else? I don't know, maybe we made this last lesson too, I forget. Yeah, I think we did, because I went over inheritance. And that is kind of, that kind of ties into what I want to do in this lesson. Right, so we had just a standard surface, and we inherited from it a special keyed surface, which allows us to have transparent portions of the surface when we're drawing. Alright, good. Now, what we're going to do today is we're not actually going to progress per se in the sprite engine. We're not going to add anything new to the sprite engine because I have to cover a topic. Probably, I can't say it's the most important topic for C++, but what I'm going to go over in this lesson is basically the thing that makes C++. I don't know, it's like the topic, it's the thing. It's hard to explain. It's the holy grail of object-oriented programming. So, how shall I go about this? I think the first thing we should do is we should close off our solution. If you have it open, close it. And I want you to... So here, if this is the folder which stores the current state of the platformer project. And I want you to make a copy of it. How do I even do that? Let me see. Give me a second. I'm going to copy it to my desktop. It's already on my desktop. I don't even know if that's the right version. I'm just going to delete the one on my desktop. Copy this one to my desktop. Rename this one. Rename the one on my desktop. And I'll just show you guys. Even though I'm sure you can figure this out. I'll call this platformer. What should I call it? Virtualization? Dynamic binding? Platformer DB. And I copy this back into Chili projects. And there. So here it is. So this is what we're going to work on. We don't want to mess with the current state of the platformer project or solution, because the stuff we're going to be doing here isn't really part of the final engine. I'm just going to be doing a little coding here as an example to teach a new concept. And that new concept will be used later on when we code. Well, basically, we're going to be coding the code that handles the behavior of a sprite, specifically a character sprite, but it'll work for enemies too, I guess. So that behavior is going to be coded using a concept known as a state machine. And in order to do the state machine in a sexy manner, we're going to be using a language feature known as virtualization, dynamic binding. I'm thinking that there is a word for it that I was going to use and I forgot it. One second. No, I don't want to pause the video because then it's gonna fucking desync, and I hate that shit. Virtual function. Yeah. Virtual method. Polymorphism. That's the word I was looking for. That was not coming to me because I had a major brain fart. But yeah, it's polymorphism. I'm still going to name it Platformer DB. Whatever, who fuck cares? It's just a name. So, we're going to learn about polymorphism, which if you've, done a little bit of reading on C++ on your own, you probably come across this this term. But before we get there, I want to go over something that I've only really touched on, and that is inheritance. So where you have a base class or a parent class, and then you have a derived class or a child class or an inherited class or whatever the fuck you want to call it. You've got a class and it inherits from another class. So when that happens, let's bring up the drawy thing. I haven't used this tablet in like a month. What happens? Well, so you have a class, and it's called surface, and you have another class, and this class derives from that class, and we'll call it keyed surface. So what that means is you have surface, you have the class surface, and that class, let me just put this up here, surface, it's going to have a bunch of methods and or member functions, and it's going to have some data, right? So I forget what kind of data and member functions and shit Surface has in here. It has width, it has a height, and it has an actual pointer to a block of memory that stores the pixels for the surface, right? So for your data, you've got fucking width, height, and surface. It's probably a stupid naming when you think about it. The class is named surface, and then one of the member data or data members in it is also named surface. Well, I'm not going to change it now. But in hindsight, I would recommend you would name this something else. Maybe pixels or something. Surface dot pixels. Yeah. That's what I would name it in hindsight. But whatever, it's just a fucking name, right? And then for your member functions, you're going to have, of course, the constructor, surface. You're going to have the destructor, surface. And you're also going to have draw. And that's it, maybe. Let's see here. Constructor, destructor, draw. And that's all you need. Now, when we inherit from this, what we get is I think I should make that bigger. Bigger. Okay. Here we have keyed surface. Keyed surface. Why is it that I always get hungry right when I'm recording? It's very inconvenient. I'm gonna copy this. No, wait. Yeah. I'm gonna copy this stuff. Copy. Paste. Good. And I can control this one. Oh, it's totally not gonna fit in there. Why do I always gotta be so cheap with the space here? Okay. No. Delete that shit. Don't worry, I'm building to something good here. I hope. Probably not. Probably just a wasting your time. But, well, you get what you pay for, right? Here we go. Okay. Ah, you had to ruin it at the last minute. You bastard. Okay, I'm gonna make this like really big now. Kind of, I could have made that bigger, really. I mean, why fuck around? We got all this space. Let's make the biggest fucking thing that you can. Okay, that's good enough. Now, move this layer. I'm gonna move that over here. Yes. Oh yeah. And then here we have extra data. So keyed surface, first of all, it inherits from surface, so it gets everything that surface has. And it also gets the things that it has. So it has a draw. Fuck. So it has its own constructor. Keyed surface. And it has its own destructor. Keyed surface. And it has draw. My tablet's getting all weird. And down here it has the key color? I forget what I called it. Anyways. Alright. So it has all this stuff, and it also has this shit. Now there's one little thing here. And that is, there's draw in the child class, but there's also a draw in the parent class. So what happens is this draw overrides this draw. So you can sort of cross this draw off. Because when we're accessing a keyed surface and we call draw, we're using this one, and we're forgetting about the old one. So you can add shit to the old class, like adding a new data member, key color. You could also add new functions. But you can also replace old shit. You can't like really delete stuff from the class, not actually. But you can add new stuff and you can replace old stuff. Now, let me just make sure here. I am interested in something here. Now the other thing is keyed surface contains basically a whole surface object. Any keyed surface object will contain a surface object at its very beginning, plus this stuff tagged onto the end. I mean, an object, it's really only just the data, right? So a keyed surface object will have the width, height, and surface at its beginning, and then at the end it'll have the key color tagged onto there. So So it has a fully functional surface basically within it. And in order to initialize that, the surface object, or the surface object that's contained within the key surface object, you can, or in some cases you must, call the original constructor here. So when I'm constructing my keyed surface, I call the constructor of its parent first, and that constructs everything about it in the parent, and then I just initialize the thing that isn't in the parent, which is the key, and then you're done. Now here's the other thing. When keyed surface dies, it calls the keyed surface constructor, but it'll also call the surface constructor because there's a surface object trapped inside of the keyed surface. So when you destroy keyed surface, the surface destructor is also called I think. Let's do a little experiment here to make sure, because I don't want to feed you guys bullshit. And there's a little tricky thing about destructors that we'll get to later on when you're inheriting. So I'm going to put a breakpoint here, and then I'm going to start. Now in the game.h, all we have is we have a surface sequence S, and the surface sequence has keyed surfaces. So we're not using any normal vanilla surfaces, we're only using the keyed surface. So when, where are we at? Where am I at here? Gotta make sure I'm not doing something stupid. Game. Okay, I'm in game. So this is an embedded object embedded into the game object, and therefore when game is destroyed, surface sequence will be destroyed. And when surface sequence is destroyed, all of the surfaces will be destroyed, and all the surfaces are keyed surfaces. So we should get the if I'm correct, the destructor for surface should be called when we destroy all the keyed surfaces. Let's test the theory. So I'm going to start with debugging. Yeah, sure. Good. Now when I close this, yeah, I get a breakpoint here. So we get automatic calling of the parent's destructor when we destroy the child. Another thing that you get with inheritance. I mean, think about it this way. If I wanted a keyed surface and a surface that was not keyed, I could do it the way I did now, or I could just create two separate classes that are not related to each other. And if I made those classes that were not related, I would have to duplicate this code in both classes. And I would have to duplicate this code, right? Because this stuff is common to both classes. And the only difference is the draw is different and the keyed surface has an extra member. So by inheriting, you can get code reuse, which is good, but it's not the main reason for inheriting. So I just want to make a warning here. This is very important. Don't use inheritance as just as a way to get code reuse. That is bad. You should use inheritance because it fits the actual system. First of all, you shouldn't really be forcing it. And second of all, there is a good reason, a design reason to use inheritance. Not just because it fits and you can reuse some code, but there's an actual thing that you can do with it. And that's what I'm going to get at. That's the polymorphism shit. But in this case, I wasn't really looking at polymorphism for my inheritance. I just inherited because it made sense. And I'm going to tell you why it made sense, because there's a right way to do inheritance and there's a billion wrong ways to do it. So the basic idea of inheritance, I'm going to delete all this shit now. Die. Whoa. Shit. Okay, I didn't want to do that. I repent. How do I all select and then delete it? Yes, and then deselect. Okay, what was I talking about? Oh yeah, the reason, the way that inheritance works and the kind of paradigm that you should be looking at is inheritance goes from general to specific. So for example, you might have a class that's like animal, and then you might have some other classes that are like this, and it might be reptile and mammal, right? Different subgroupings of animal. Animal is very general. Reptile and mammals are specific kinds of animals. They're mutually exclusive. No mammals are reptiles. No reptiles are mammals, as far as I know. And then here you can have, like horse and dude. And here you can have like, I don't know, snake and I don't know, something else. Dinosaur. They're reptiles, right? I don't really know. It might be different. I have no idea. Wait, reptiles and amphibians, they're different, right? Yeah. Anyways, that's how it works. It goes from like really, actually dinosaur isn't actually a specific species, is it? Shit. That was stupid. It still works, but it wasn't what I wanted. What's another reptile? Iguana. Do you spell iguana with a Q? I don't think so. That's how I spell it. Iguana. I'm pretty sure I'm not spelling that right. I kind of suck at spelling, actually. But you get the idea, right? You're going from something very general and you're making it more and more specific. Although generally in inheritance, you don't want to go through too many layers of inheritance. And here you would add things that you would try to add only things that all animals have. I don't know what those things would be, but it depends on your program. But if you were like keeping track of like body statistics, you might be like things like temperature or blood volume or something. I don't know, whatever. Things that any kind of animal would have. And then here in mammals, you could have extra things like, I don't know, like boobs. Mammals got boobs. In reptiles, you might have, I don't know, like a function method called hatch, because reptiles, they come from like hard-shelled eggs or at least eggs that are external to the body, right? They got a hatch, is what I'm saying. And then specific things like iguanas and snakes might have things that only pertain to those things. Like snakes might have a slither method, and so forth. And you get the idea, right? This is the way you should be thinking of inheritance. General to specific. And you try to factor out all the things that are common to some class or some level in your hierarchy. You want to put that in the parent class. And all the things that make them special, you take care of that in the derived classes. That's how inheritance works, kind of. Yeah, we'll say that's how it works. I'm hungry. So, why am I talking about this shit? How does this help us to make a wicked ass game where Mario jumps on shit and flips out like a ninja? Well, it all goes back to this virtual function crap. But instead of just explaining everything in words and pictures, we're going to do some coding, because that's what we do, right? That's my thing. That's my motto. Just jump in there and write some code. So we need a little challenge. We need a little something to focus our sexual energies on. Wait, no. Scratch that last part. But we need something here. Stop making pausing things. Breakpoints. I'm forgetting my terminologies. Wait, where is that other breakpoint going? I must have deleted it, right? Yes, I deleted. Okay, so here's the deal. We're going to make some tile, or sort of tiles. We're going to make some things that are like tiles that go on the screen. Like, you know what a freaking tile is, right? You've played like any like Super Nintendo game. You know what a tile is. And here's the thing about tiles. Let me get the Google machine up here. Now the Google machine is going to tell us about tiles. We're going to look at what's the name of that game? Flash back tiles. There was like a good thing about this. What? Yes. Okay, here's the image that I'm thinking of. Now you got your tiles here. Here's flashback. That's really small. I was hoping for a little bigger picture. How do I make this bigger? I could save the picture on my desktop. I'd save that. And then what? Let me just make sure there isn't a bigger one on the page first. No, this one looks bigger. I can't even tell anymore. Wait, if I click on it, will it go bigger? No. Wait, if I do this. Yes, kind of. It's kind of getting blurry, but oh, now my size is going to be all messed up. I don't know how to get back to the normal size. Anyways, here we go. Look at this. These are the tiles of the game. Now, some tiles, like look at the bridge here. These tiles are kind of like partially obscuring the character, but not completely. And there are other tiles where they're basically completely obscuring something. Like, look at this tile. This tile is completely solid. There are no transparent pixels in it. You just plunk it down and it just chilling out there like a big nasty turd. And then you got these sexy tiles here that are all like see-through and shit. So, you could do one of two things. You could treat all tiles exactly the same and just assume that every tile may have some transparent pixels and use the same routines to draw every tile. Some tiles will have no transparent pixels, and in that case you'll just be wasting a lot of time, because drawing, I think I've covered this before, but drawing transparent pixels is drawing with transparent pixels is a lot slower. Because look at this draw here. It's just two loops with a put pixel inside. But in this one, you've got a test here. You've got a test inside of a loop. So you're going to be running this test lots of times, especially if it's like a really big surface that you're trying to draw. And the thing about tests is that they fuck up processors because of the way they work. You want to avoid branching as much as possible. If statements. So an if statement, you might think, oh, it's only an if, right? If anything, it'll speed up the processing because you're going to skip some put pixels. Wrong. Ifs will slow the fuck out of your loops. I'm not going to explain why. If you want to know why ifs are the devil, then look up branch prediction. Look up superscalar processors or architectures. Look up pipelining, and you will realize that if statements indeed are the devil, especially when they're inside of a nested loop that's going to be run an ass ton of times. So we can say, who the fuck cares about performance, and just draw all of our tiles as keyed surfaces, and that would be fine. Because, we're running on like super powerful processors that will definitely be able to handle this shit. But there are going to be other cases where you're going to want to differentiate behavior in order to get an optimization. So here we probably don't need to run the optimization. But there will be other cases when you're making real games where you will want to optimize, and they'll be similar to this situation. So this is one example of a situation where we're going to be able to use polymorphism. But first of all, let's just do that thing that I was talking about. So what we're going to do is we're going to plop down a bunch of these tiles onto the screen. And some of them are going to be transparent, some of them are not going to be transparent. Now, how to explain this to you guys? I could make a new class called Tile. I think I will do that. Ugh. Yeah. How do I want to handle this situation with you guys? Okay, we're not going to make a new class called Tile. We could, but we're not going to. For the time being, we're going to just add to game. I'm thinking here. I really want to pause the video. Actually, now that I think about it, Camtasia was updated. There was a new version. Maybe I could pause it without fucking up my synchronization. Let's do that. Alright, let's see if that totally desynchronized my audio with my video and fucked everything up. Good experiment. Okay, so I figured out how I want to do this, and I do want to make another class. So let's do it properly. Let's add a new we'll add a new thingamajigger. I wonder, I've never tried this in a while. Add class. Because I'm pretty sure I don't like adding class using this thing because it just pisses me off, is what it does. Why can't I add a C++ class? Just add? How does it work? I'm afraid to hit this add button. I don't know how it's going to happen. Oh, there's a thing. Base class. No, there's no base class. Yeah, you know what? Fuck that. I'm just going to add this. Fuck you. I'm just going to add a thing. H-file. Add new item. H-file. We're going to call it tile. So we're going to create a tile class. And we're going to include surface. Nope. Surface. What? Fucking every fucking time. I'm pretty sure I ranted about this in the other video too. No, I don't want to fucking, no. Just remove it. Permanently delete it. Burn it, send it to hell. Okay, I want to add a new item. It's going to be header file. And it's not going to go where I don't want it to go. It's going to go here. It's going to go here. I rue the day that I ever made this fucking assets folder. I'm like, I'm going to organize this shit. I'm going to keep my source code separate from all my, like, you know, other shit. No. Not the way to go. Tile. I'm going to capitalize the T this time. Okay, now, this isn't going to fuck up, is it? We're going to be cool. No, we're not going to start with the wrong symbol. And here we go. Surface sequence. Oh, don't forget the thing. Yeah. Not standards compliant. Suck my dick. And what else? Okay, so we need a tile class. Class tile. Now, our tile class. Now, if you were listening to me and paying attention, you know that we're gonna want two different kinds of tiles. we're going to want tiles that are transparent, and we're going to want tiles that are solid. So you might think we need two different classes. But you know what? We don't. Not really. Because here's the thing. Here's the thing. I want to explain this in an awesome way, but I don't think I can. So, first of all, surface pointer to? Yeah, we'll make it a pointer to the surface. Public tile. Wait, public tile. Now, how do we construct this mother? So a tile is going to have a surface. It's going to have an int x, int y position. And that's it. That's all she wrote. And then we'll do a void draw. And I guess we'll need graphics. So, what's the graphics again? Fuck. D3D graphics ampersand GFX. Do I have D3D graphics, or do I have to include something? Apparently not. And with that, I guess we're going to need, here we're going to need int x, y. And then we go here and we call surface pointer to draw x, x, y, gfx. There. Alright. So that should be everything we need. We just gotta actually write the constructor. So actually the constructor will just be nothing. And aw, dick. Surface is surface. Nope. Nope. X is X. Stop it. Y is Y. There. Okay. Why are you not making it so I can collapse this thing? Whatever, jerkface. I don't care. Yeah. So that's that. Let's create a tile and draw it. Oh yeah, I guess I gotta put those tiles in the tile thing. I'll make it so you can download these, but I mean you could make these yourself if you wanted. It's just bitmaps. One of them is just gonna be a solid blue color. The other one has some gay ass color on it. Not that there's anything wrong with that. It's just an expression. But yeah, there's this weird ass color that I forget what it's called. It sucks. So I use it as the whatchamacallit? The transparent color. Because I am never going to use this color in an actual model of anything. Because it's horrible. Now, I'm going to take these things and I'm going to put them in, I want to say here. Yeah. Why is there a bitmap of the dude here? And he's like the old dude. He's not the new awesome dude that I made with my program. Why is that dude there? Go away. I didn't. No, whatever. Fuck you. Oh, you're going to the garbage. Empty you. Now you die. Okay, so. We got our tiles here. Sol tile and trans tile. So we's gonna do. Okay. Wait a minute. Okay, I'm gonna make it the responsibility of the tile to destroy its surface. Even though the surface is going to be created outside of the tile and passed as a pointer, once the tile has acquired the surface as a pointer, it's going to be the job of the tile to destroy that surface. Let me just get that out there. It's very fucking important when you're working with dynamic memory allocation that you make it clear in your head which object has the responsibility or the onus to destroy resources. So we'll delete surface there. Good. Good. Now, we'll go to game.h. We're going to create a... Oh, I have to include the tile here. Include tile. Yes. And here we're going to do tile T. Now we have to actually create the tile. So we go T. Nope, not that one. Yes, we got to create a surface. So let's create a new surface. Why does it always default to this one, which is not the one I want? Ever, anytime, ever. I just never want it. Here we go. So it's called soltile.bmp. And there we go. We got the one I don't want again. There's probably a keyboard shortcut. Oh, all I need is the file name. Oh yeah, to create the surface, all I need is the file name. But here, I need an X and a Y. I don't remember our dimensions. I'm going to say 4. Wait. I want it so that the dude can run behind it. So his X is 0, Y, 200. So I'm going to make this one 220. Wait, his X is going to be 400. I don't know. Make this one 230. Okay, good. I think that's good. So we created a new tile by creating a new surface, passing the pointer to it, and also passing its position. Here we update the sprite, or not, it's not even a sprite, it's just a surface sequence. And here we're going to go tile.draw, GFX. There. Okay. Build, find errors, no errors, hallelujah. And did I put the right name? soltile.bmp. It seems right. What could possibly go wrong? Wait, here it is. So you see the dude's running behind the tile. That's cool. Let's make another tile. Let's go to, oh, I'm so hungry, you don't even know. Okay. Tile. T2. We're getting super creative with the variable names here. I'm bringing my A game if you didn't already notice. So now we're going to create a new, and here's where it gets interesting. We're going to create a new keyed surface. Think about this for a while. Just think about this for a second. D3D color. Wait, D3D color is a proper macro, isn't it? Fuck, now I can't even remember. Yeah, wait, no it isn't. XRGB, that's what I needed. Underscore XRGB. There we go. Now, what? No? No underscore? Just XRGB? No, that's not right. Fuck, I can't remember what the name of the... Is it good? Yeah, it's good. There we go. Okay, so red was 255, green was 0, blue was 255 for that ugly ass color. So here we create a keyed surface. And we're going to put this one at 450 because tiles are 50 wide, the ones I made. We'll put this one 230. So what just happened here? Make a prediction what's going to happen. Remember, this constructor is asking for a pointer to a surface. Here I pass it a pointer to a surface. Here I pass it a pointer to a keyed surface, which is not what it's actually specified to take. What's gonna happen? Will it compile? Yes, it will. Does this not interest you? Oh, I'm gonna make this a what was that? It was a trans tile, but doesn't matter. It's just a string. So I can pass a pointer to a keyed surface. And the compiler is like, yeah, that's totally cool. I'm cool with that. Now, does this not strike you as weird? Imagine I did some other like stupid shit. Like, for example, I went int foo float pointer to bar. Bar is a floater to pointer to a float. And then I went bar is equal to the address of foo. The compiler is going to be like, what? Where is it? Cannot convert from int pointer to float pointer. It'll be like, what? What are you even trying to do here? Are you fucking serious? How long have we been going over this shit and you still can't get this shit right? You are an embarrassment. And yet, this is fine. And the reason why is, well, I deleted that nice drawing I had, but basically, where's my, oh, here it is. Keyed surface contains within it an entirely intact surface. So if you have a that's surface, a pointer to a surface, it's totally cool with pointing to keyed surface because keyed surface has a total like a entire surface within itself. It has everything that surface has, so you can refer to it just as if it were a surface. And that's fine. You won't be able to get any of the things that were added later on. You won't be able to access any of the extra goodies, but you can treat it like a surface, and that's cool. So make a prediction as to what will happen when I run this. I'm going to draw two tiles. What's it going to look? Oh, I'm not going to draw two tiles yet because I didn't actually do it. Derp. I just saved myself a little bit of embarrassment here. Okay, now make a prediction on what's going to happen now that I fixed the most obvious of errors. No, let's just do this one. Ooh, so I've got my two tiles here, but this is definitely not transparent. Even though tile 2 has a pointer to a keyed surface, we got no dice here. Now, can you think of why that is? Well, basically, if we're using a surface pointer to a keyed surface, from the point of view of the compiler or the CPU or however you want to think of it, all it knows is it's pointing to a surface. It has no way of knowing that it's a keyed surface. All it knows is it has some kind of surface. It might be a base surface, it might be a derived key surface, but all it knows is I'm pointing to a surface. So when you call draw, you're gonna call draw for surface. Even though the object itself is a keyed surface, you're going to call the old draw function. Because that's all you know is there. You can't guarantee anything else with that pointer. Wait, now I'm lost. Where am I? Here I am. Okay. So what are you gonna do? I mean, we could go back to the idea of just making every surface a keyed surface, like going to tile, changing surface here to keyed surface pointer. Let's try that. Keyed surface pointer to surface. We don't have to change anything else in this file, but if we do that, where is it? Where is my error? Tile surface member cannot be initialized. Here we go. Keyed surface. Oh wait, I should change this one too. Right, because we want to take a pointer to keyed surface. But already there you've had a big hint as to what is going to happen. Tile cannot convert parameter 1 from surface pointer to keyed surface pointer. So here's the other thing, well, one other thing among many about inheritance and all that happy shit. Let me just do something here. I'm going to make my inheritance diagram. So here we have surface, and here we have keyed surface, which inherits from surface. It contains a surface inside of itself because it's inheriting. Now, this pointer can point to your vanilla surface or your keyed surface. That's totally cool, right? But if you have a keyed surface pointer, you can point to a keyed surface, but you cannot fucking point to a vanilla surface. That shit is not cool. Why do you think that is? It's pretty fucking simple. Basically, if you have a keyed surface pointer and you where is it? Here it is. So you have a keyed surface pointer here, and you try to point to a surface. Well, think about it. The pointer is a keyed surface pointer, and it's going to expect that there will be things like this key here that there isn't, and it's going to expect that there's going to be this extra draw function, but there isn't. Right? Because keyed surface adds new stuff onto surface. So go back here. If I use keyed surface to point to the base class surface, it's going to expect that there's stuff in here that there actually isn't. So it's going to try to call the overriding draw. Okay? Because it's going to say, I have a keyed surface. Well, it's a pointer to a keyed surface. So it's going to say, I'm pointing to a keyed surface. So I am going to call keyed surface draw. It's going to call this draw. And in this draw, it's going to try to access the key. Right? Except it's actually pointing to a vanilla surface. And a vanilla surface doesn't have a key. There's a key here. There's no key there. So it's going to try to access something that's not there, and that's never good. So that's why surface can point to a surface object or a keyed surface object. But keyed surface can only point to a keyed surface object. It cannot point to a vanilla surface. That is not possible. So this is no good. we have to tile has to be it has to be a pointer to a surface so that it can handle both keyed surfaces and normal surfaces. The moral of this story is that if you want to be able to have a single pointer point to a bunch of different objects, it has to be of a more general type. Specific type pointers can only point to their specific objects. Now, so we're back to our original problem, which is look at that. We're not getting our transparency in here. Even though we have a keyed surface, we've got no way of calling the proper draw function for it. Except we do have a way. And that is the whole crux of my argument here. The whole reason for this tutorial. So as things stand, where's my thing? This surface pointer here is all we know about the object. So we can't tell if we have a keyed surface or a normal surface. We can do something very special that will allow us to call the correct function regardless of what kind of pointer we have. And that little something something is known as a virtual function. So if we make draw virtual, and I'm not sure, but I think you might have to do it here too. Virtual. Now, even if we call draw with a surface pointer, that call is going to get dispatched to keyed surfaces draw function, if it is actually a keyed surface. If it's a normal surface, it'll just go to the normal surfaces. But if it's a keyed surface, a surface pointer will dispatch the call to the keyed surfaces draw function. And if that doesn't sound awesome to you, then you're clearly you don't have the appreciation of this language, because that's amazing shit. So we have a surface pointer we're going to call draw. But even though we don't know which object, we don't know from the point of view of the pointer and whoever owns the pointer, we don't know what's at the other end of this pointer. We don't know whether it's a surface or a keyed surface. But when we call draw, it's going to call the correct one. And the reason is because when you make this, where's my thing? When you make this function here, when you make this virtual surface and keyed surface, they're going to store a little bit of information inside of themselves, which lets them properly handle the function call so that it goes to the right function, depending on whether it's actually a keyed surface or whether it's actually just a surface. So making a function virtual will actually add a little bit of hidden data onto your class, your objects. And there's a little bit of overhead too, but it's not really that huge, especially these days with proper optimizations, and CPUs are also optimized for these kind of virtual functions. So it's not a big deal. But just be known that there are hidden things that get added when you make a function virtual. Now let me build, make sure I didn't mess something up here. Now if I do this shit, it should work unless I mess something else up. Okay, so I messed something else up. Bollocks. Wait. Build? That's good. Debug. Let me just try something here. All right. So it looks like the actual color was 255 1 255. I fucked it up kind of. But so if I use this as the color key, then we get the proper transparency here. So you might say to yourself, well, then it really wasn't the virtual shit, was it? I mean, it wouldn't have been transparent either way. So to prove to you that I'm not full of shit, I'm going to go here. Wait, where was it again? Surface. Yeah, here. Go back to surface. I'm going to draw just a normal function, a normal overloaded function, not virtual. Build. And you see now there is no transparency. So undo, go back here. With virtual functions, we have transparency. So when we call draw using a surface pointer on a surface, we get just your normal drawing. And when we call draw using a surface pointer on a keyed surface, we get the keyed surface's draw function. And that, my friends, is what we call polymorphism or dynamic binding. Virtual functions, that's what it is. And it allows you to have a single pointer, and although the pointer, from the pointer's point of view, it's only one kind of thing, or you don't know what kind of thing it is, you can have that pointer point to a whole bunch of different shit, and all that shit can behave differently, and it's all from the same pointer. And this allows us to do a lot of neat shit in C++. And this is probably the main reason why you should be inheriting stuff. It's to get access to this virtual not virtual inheritance, but virtual overloading of functions, which will allow you to have well, it allows you to do a lot of different things. But like, let's say you have a game and it has a ton of different objects in the game environment, right? Like hundreds of different types of objects. And without this kind of virtual inheritance, you would have to have separate arrays for every different type of object. And you'd have to run through each of those arrays and call the draw functions or the update functions or whatever. But if you have virtual inheritance, you can have all the objects derived from some kind of a base or interface, which I'll get into later. It's a special case of inheritance. So you could make an interface base class, which is like drawable. And all that drawable has is it declares one function, which is the draw function. And so all classes that derive from drawable, they all also have draw functions, but their draw functions are all different. And then you make a single array, and you call it the drawable array, and it holds every object in your entire game or in your entire environment. And when you call draw on each of those objects, it will draw them from their own unique draw routines. And that's just one example of what you can do with dynamic binding, polymorphism, right? That's where the word polymorphism comes from, right? Poly meaning many, and morphism meaning shape, I guess. So you have on one end, on the client end, where is it? Game. You have tiles, right? And these tiles, they just have pointers to surfaces. But on the other end of this pointer, you have different kinds of objects different shapes, if you will, and they act differently. They have different behaviors. So even though from the perspective of the tile, they're all just surfaces, on the other end, they're all unique and they all have their own ways of behaving. As many ways as you have derived classes. So, about 1 hour of tutorial. That's a good round number, I guess. So that is polymorphism and inheritance in a nutshell. I mean, these are pretty deep topics. There's a lot to go into about them. You can get into some pretty nitty-gritty details and special cases. But this is that's the Cliff Notes version, I guess. That's the overview. And this will allow us to take things to the next level. The next thing I want to work on is basically controlling the dude guy here, doing shit like jumping, running both directions and shit like that. And we're going to handle that. I'm actually in the process right now of working it out beforehand, because I want to make sure that this is the way we're going before I actually do it in the tutorials. I don't want to waste too much of your guys' time. But we're going to handle this movement and other things like attacking or whatever using states, using a state machine. So everything like being airborne or being hit by an enemy in a recovery state, crouched, standing, those will all be separate states. And every one of those states is going to have a state class associated with it. And they're all going to be deriving from the main class, which is just like sprite state or something. And we use polymorphism in order to determine the action of the effect on the sprite depending on the state and the input. So, yeah, what I was going to say is if you guys want to get a leg up on the tutorials and prepare for the stuff that's coming, you can look up state machines, finite state machines, FSMs, and state diagrams, and you can just kind of, do a little pre-study there, if you want. I mean, it's totally optional, but yeah, where's finite state machine? Here it is. So there's like whole diagramming scheme. I think that's my normal text size. I can't even remember anymore. Yeah, you've got like different ways of representing states and the transitions between states. This is actually this programming concept or paradigm, or systems design paradigm, I guess, is really common in game programming. So we'll be getting to it. So yeah, that's next lesson. State machines using polymorphism.